आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. We welcome Professor Shubhra Ghosh Dastidar in this episode of our podcast, who is a computational chemist at Bose Institute. Professor Dastidar shares about his journey to his present area research.
Basically, I'm a computational chemist. I did my PhD in computational chemistry from University of Kolkata. And then in 2005, I went to University of California, Davis, to do postdoc in the same field. And then for a short stay, I was in University of Texas at Galveston. And then again, I moved to Singapore at Bioinformatics Institute, A-Star. And there I was working actually on computational biology. So the transformation from computational chemist to computational biology actually happened in Singapore. And then in 2011, in January, I joined Bose Institute as an assistant professor. Now I'm a professor here. And the broader area of my work is computational biology, and more precisely, I work in the field of molecular modeling and simulation. Let me explain briefly that the players of biology are the large and complex molecules, and people are familiar with these terms like proteins, DNA, RNA, lipids, membranes, etc. these days. So these molecules are quite large and they have thousands and thousands of atoms. And due to their complexity, it is not always explain their properties that you or someone gets from experiments. It becomes also important to visualize those molecules. So want to see them. So there is no direct way to see the molecules. There are some experimental methods, but ultimately one has to convert those information into a model, or there are ways of through which you can model in absence of experimental data. You can model such large molecules in computers, and that is not always sufficient, because let me give you this analogy. Suppose I draw a picture of a dancer, but I don't see him or her to dance, so we don't see them in action. So how could you guess what is their mechanism of function? So then it becomes very important to see those molecules in action. So that is where the need of simulation of their motions becomes important. And that is what we do. And more specifically, we are working on some proteins which are relevant for cancers, for the cancer progression and also for therapy. And it becomes very important that how these molecules are actually choreographed with other molecules, and how they're handshaking with other molecules, binding with drugs and not binding with drugs. So this molecular choreography you can simulate using computers. So that is what we are doing. And our recent findings are quite good. And we have shown that what can go wrong. So when there is a change in the molecular level, that leads to the rejection of a drug or better binding even. So this actually help in designing more novel compounds using these principles. And also these are very useful for developing software. And one of the recent works that I can mention, that this is about finding distant communication within same protein molecule, because they are large, like huge 10-story building, and you are trying to control the 10-story rooms from ground level. So this is a distant communication, and in scientific term, this is called allostery. So allostery is our one direction of investigation. We have progressed a lot, and this can tell how some of the proteins can function and how this could be interrupted for the purposes of therapy, because when the molecules are malfunctioning, the drugs can go and block them. So these information become very important.
Sir explains in great detail about the process of his research.
It requires a very large computing setup. So it's not just laptop or PC or something, or not even one server. It requires large computing setup, which at least we call them as computer clusters, if not supercomputers. So we have very good setup at Bose Institute for doing these things. And we start with some experimental data that tells that what could be the possible, one of the possible shape of the molecules. And then we model a setup relevant for the particular biological investigation. And we simulate those using, there are principles of physics, chemistry, and mathematics. And it takes a couple of months and sometimes years just to finish one setup simulation to see how the molecules are actually dancing, and then we can analyze.
Professor also explains about the collaborations for his area of research.
Even within Bose Institute, people who are doing experiments, often they encounter some kind of experimental data which are very hard to explain without the help of some molecular models and some kind of information about their motions. For example, when something is binding or when something is not binding. So that kind of explanations, they come to us and we model them, we simulate them, and we explain them, and the success is quite good here. And we also collaborate with other research institutes around Bose Institute in Kolkata. And I also had collaborations with other countries in past. In past, I was working with some groups in Singapore. And just before the COVID, I had very good collaboration with Dhaka University because they were working on salt-tolerant rice. And they wanted to know some underlying mechanisms of why something is tolerant, something is not. And using our models, we explained it. And that is published.
Sir also explains about India's position in this field of research.
See, India has this very good presence in the international market of research. And this is because we have a very well-trained manpower. See, this field actually started in late 80s and early 90s globally. And in India, it came almost in the similar time or a few years later. But since then, its growth in India is rapid. So we have a very good visibility. Many people are working in this field in India.
Professor Ghosh Dastidar also highlights how Indian industry can benefit from this line of research.
See, the Nobel Prize was awarded in particular this field in 2013 in modeling and simulation. And the statement that they released was like this, if I am not wrong, that this year's prize is about taking the chemical experiment to cyberspace. So you can see the change. So now the things are going to the software industry to predict whether something will work or not. So that's a huge gain for industry because before any money or manpower is invested, everyone would like to plan first based on this computed information. And you see, this age is data-driven age. Even in business, marketing, data is everything. Data is the power. So here also in biological research, any plan, any experimental research, also these days are starting with some data-driven analysis. So, and modeling and simulations are contributing a lot. And pharmaceutical industry particularly have integrated this modeling and simulation in their drug design pipeline. And it's now an integral part. No one can go without this field in industry, biotech industry.
We thank Professor Ghosh Dastidar for his valuable insights.